Okay guys, so in the previous video we just wrote basic functions to configure and to send data through our SPI. Again, no interrupts, no DMA yet. I'll do those in a couple days. Just regular polling, the TXE and master mode, half duplex. So now in this video I'm gonna code or program an actual little driver for these RGB LEDs, and we'll go into the data sheet for these. So this, and we're obviously going to use the SPI functions that we wrote in the last video. So this video is more about the LEDs and writing a driver for those more than it is actually on SPI. Actually, there's nothing left to do with the SPI. We already have the functions that we need. So yeah, so maybe this video kind of falls out of the scope of that. So I'll just title this something else. Anyways, so let's jump into that and start doing that. I also set up a little webcam here. This is the camera that I used to record my face with before, and it sucks, but it's gonna serve a purpose now to hopefully let me show you guys. Hopefully I can record the LEDs there. I will have to, when I have the webcam on, I'm gonna turn off my lights. But yeah, so let's get into the code and start doing that now. So let's get into desktop. Okay, so first let's look at what the RGBs, what they need, and what kind of information we have to send to them so that they can actually work. No, camera. Okay. So the LEDs, we already looked at the timing. We know what the timing information is, and we set that up. So now let's look what information we have to send it. So basically it says that this is the entire frame for the information we're going to send. It's all of this, right? And then this is an explanation of what all this is. So first we have to send it a start frame, which is 32 bits, which is nothing more than 4 bytes. And it has to be all zeros. So that's what's going to tell the LEDs that this is a start frame bit. Oops. And then after that, we're going to send it the actual LED frames. One LED frame, in other words, another 32 bits for every single LED that we have. So I have 144 LEDs on the strip, so I'm going to have to send this LED frame bit 144 times, given the values that I want for blue, green, and red, and this global brightness here. And then at the very end, you send an end frame bit, and this signifies to the strip that you're done. And then that has to be all ones. Another thing to note here is that the first byte consists of 3 ones in the significant bits, and this global is what controls the global brightness of that specific LED. So obviously you don't have 256 bits of resolution because the first 3 are already ones. So if you pull out the calculator here, you'll see that 111. So those that 111 is actually equal to hex E0. So the first byte is gonna always be hex E0 plus whatever you want to put in here, right? And then that resolution is just these bits right here. That's how much resolution you have of brightness, and that's just 5 bits. So you only have 31 or 32, including 0 bits of resolution for your brightness. From 0 to 31 is how much brightness you can put. So whenever you're sending the brightness, let's say you want to put brightness 31, which is all the way up, you're going to do 31 plus this, which is E0, or not even plus, but or. You can or it and you'll get the same thing. So yeah, so that's the thing. And then you're going to send the blue from and that 8-bit resolution from 0 to 255, the green and the red, and you can mix colors like that. All right, so that's what we need. So what I'm gonna do is I'm gonna put all of this in an array. I'm gonna have these start frame bits. That's just 4 bytes of zeros. I don't need an array for that. But the LEDs are 144, so I'm gonna make an array of 144 rows, and each one of those rows is going to have another it's gonna be a 2-dimensional array, so it's gonna be 144 by 4, and it's gonna be index 1, index 2, index 3, and index 0, 1, 2, and 3. So it's gonna look I made a picture to explain it. It's gonna look like that. So it's gonna be an array, index 0 in the first dimension, or the second dimension here. You're gonna have a global, which is the brightness, red, green, blue. And I know the order is backwards because here it says blue, green, red, but as long as that when I'm transmitting it, I do it in the proper order, it doesn't matter. It's just this is easier for my eyes to see, because you know you're used to saying RGB, but here it's kind of backwards. But so the order that it's here doesn't necessarily matter, at least in this image, as long as we map the red to the third index and the green to this the second index, stuff like that. You know what I mean. Anyways, so yeah, so let's go ahead and start doing that. What was I doing? Oh no, Kyle. Okay, so this is just the code from the last video, which is just our SPI setup and our SPI send. So we're basically done with that. So let's start making some cool stuff that we need. So I'm going to start by making some definitions. Well, first let's make that array. We'll call it LED. I don't know. I'll just call it LED array, I guess. LED, and it's going to be 144 by 4, right? Yeah. Hello. So here's our array. Now I'm gonna actually make a define for that, because that number will probably be used many times. So LED count, and instead of addressing the indexes by 0, 1, 2, I'm gonna make some defines for them. I'll call this one bright, and I know that's index 0. Define red, define green, define blue. So this is where it's important. So in my eyes and in my functions, I'm going to call it RGB, but red is not really the first one. So 0, 1, 2, 3. So red is 3, green is 2, blue is 1. It's actually backwards. So 3, 2, and 1. And this is just so that when I access this array, I'm not typing 0, 1, or 2 or anything like that, because it's going to be easy to forget. I'll just type in red or green or whatever. So, and this is just because it looks prettier. Okay, so I have that going on. Brightness, or you know what, maybe I should call it global. They do call it global here. I'll call it global. That's what they call it over here. Global value, global brightness, same thing, whatever. So there's a constant that always needs to be put into the first, which is as we saw in the calculator, which I closed. But anyways, it's E0. So this is E0 that we always have to put in the first bit. So that's another thing we're going to keep track of. Okay, so I'm going to have some functions for this. I think an important function is to clear or initialize the array. So let's call it clear array. Another function is going to be to actually set a specific LED. So if I want, LED 28, I want to set that specific LED. So I'm gonna have a function to set an LED, or to change the brightness, the color, whatever you're gonna do. Let's call it SK because that's the name of this part, SK98, whatever. So let's call it SK set LED, and then that function is gonna take an it's gonna be all 8-bit. It's gonna take an index, right? Because you're gonna tell it which LED, so we'll call that index, and then it's gonna take a brightness, or global, I'm sorry, global brightness, whatever, and then the RGB values, right? So red, and again, right here, the order that I'm gonna type it here doesn't matter as long as that in the actual function I put the right one where it belongs. Okay. Unsigned integer 8, red, green, and blue. Okay. I guess another function, because this just updates the array. It's not really transmitting anything. It's not going to transmit in SPI. Or you can have it transmit in the to the SPI, right? But what if you want to update more than one? You can just call this function like 20 times, update all the LEDs you want to, and then at the end update the actual the LED strip. So I'll have a separate function for that. We'll just call it update, and that's not I don't think that's gonna take any parameters, at least that I can think of yet. Anyways, another thing, like the way that I'm doing this, maybe you can think of a better way to do it or whatever, but this is just to get an idea and the gists of what I'm trying to accomplish here. Okay, so now that we have these function prototypes made, let's go ahead and actually make these functions a reality. Oops, what the hell did I do? I'm gonna start with the clear array because, well, it's just fun. Okay, so in this function, my intention is obviously just to initialize the array with zeros in all of the indexes. However, you have to remember, let me pull up that picture. Did I close that picture? Oh, I closed that picture. Anyways, you have to remember that I'm not going to put 0 in all of the index. Index 0 with the global brightness is not going to be 0. It's going to be at the very minimum this, right? My brightness can be 0, like all these bits can be 0, but the high bits have to be 1, 1. So it's going to be, so I have to make sure I do that when I initialize this array, or clear this array. In reality, I mean, it's okay, it's initialized array, but you can also use it to just turn all the LEDs off. So I'm gonna make some counter variables here, I and j. Oops. Actually no, because okay, just for my sanity's sake, let's do I and j. Oh my god, sorry guys. Okay, so we're gonna loop through all of the LEDs here for I is less than LED count. Told you we're gonna use that number more than once, right? Oh my god, guys, I'm forgetting how to, I'm telling you, that's what happens when it's been almost a year since you've done anything. I is less than LED count I plus plus. Okay, so then we're gonna go from the first LED index 0 to the last one. All right, now when I I am going to do 4J. And now we're going to loop through the actual indexes of the LED. So now we're going to go, now we're at a specific LED, let's say LED 1, and now we're going to fill these in. I'm going to skip this one, and I'm going to do these 3, because I'll put that one, I guess, on the outside. So for J, so we're going to skip that first index equals 1, while J is less than 4. Okay. And we're going to go into LED array at index I, index J, and we're just going to write 0, 0. So all the 3, the red, the green, and the blue are going to be 0, 0. But for every single LED, I want the 0th index. This one, which we called, I think we called global. Yeah, we called it global. I want that one to be E0. That's not going to be 0, 0. That's going to be E0. So this will that's really it. So this function is going to initialize the red, the green, the blue to 0, and the brightness to E0, because that's the only bit that is going to control the brightness is the other bits. I feel like I'm missing something. Or nope, we're good. Okay. All right. So yeah, so that's that. Now I guess what's the next function? LED update. All right. So obviously in this function is going to be where we set a specific LED to whatever values we want, right? And I'm trying to think how I'm going to do this. Okay, so let's say I want to send an index of an LED 10. Let's say I want the brightness to be 0. What happens when the brightness is 0? I can't just set that value to 0 or something. Okay, you know what? I'll cross that bridge when I get to it. So LED array at index, at what index? At index, right? At whatever index the user passes through. Red, which is defined, red is not this red that they're going to pass. This red is index 3, which matches with this index 3. So it's going in the right place where it belongs, right? So at index 3, put the lowercase red that they passed. And we'll do the same thing for green and blue. Okay, now the brightness. So what happens if they pass okay, let me show you my dilemma here. So if I have index and the brightness, the global brightness, so here global. So if they have a brightness of 4, right? So here's global. If I put global like this, I can't just put if they put 0, let's say they want a brightness of 0. If I put 0 here, then what's going to happen? It's going to put 0 into this whole 8 bits, but it can't be 0. It has to be at the very least 1, 1, 1, 1, right? So I think I can just OR it. What happens when you OR something with 0? That one or that one equals 0. Because by default, I've already initialized the array with E0 there. So I should just be able to put global is going to equal 0x E0 ORed with that. So it's going to look like that, right? Because I can't just put equal to global, because if they put 0, then it's going to change the whole thing to 0, but I need at the very least this to be there. So E0 ORed with whatever. But what if what if they pass a value like 255 or 300? I don't know. Okay, well, yeah, I'm not doing extensive error checking here. Like, okay, what if they pass like 255 or something like that? Well, when I order that with E0, it doesn't matter. Okay, yeah, it's not gonna matter. Yeah, so if they put 0, it's gonna be 0 or yeah. Okay, this should work. If it doesn't work, I'm gonna have to put in an if statement here. So that's just to set a specific LED. Again, it's not transmitting anything to the actual strip. So this other this is going to be the meat of that. So how do you update the strip? The strip gets updated by sending this start frame, all the LED stuff, and then the end frame. So we have to send 4 bytes of zeros. So let's handle that. That'll be the start frame there, right? And it's nothing more than 4 bytes of zeros. So let's just do a little counter here. So I equals 0 while I is less than 4. And then we're gonna send on the SPI, we're gonna send 0 4 times, right? So our SPI underscore send, send, and 0x00. So we're gonna send 0 4 times, and that's it. That's our little thing here, our start bit frame, LED frames, and then start frames, end frames. And that's going to be the exact same thing as this actually, except it's going to be all ones. So that's the end sequence. Now this is the fun stuff. So we're gonna do, well, again, we're gonna need to do another counter because it's a 2-dimensional array. So we're gonna loop through our LED array and send everything that's in it. So for I equals 0, while I is less than LED count, I plus plus. Okay, right? And then we're gonna loop through the second dimension for j equals 0, while j is less than 4, j plus plus. Okay, and then we're gonna send on the SPI I and j respectively. SPI underscore send. What are we gonna send it? We're gonna send LED array index I, index j, and that should do it. Yeah, that looks about right. Hopefully I'm not missing anything. So yeah, so we go back to our main. We've set up our SPI. We called our function to set up SPI. I'm gonna go ahead and clear the array, which will initialize everything to 0 and stuff like that. And I'm going to let's set an LED. What did I call it? SK set LED, SK update. So SK set LED. So let's set LED 10. The brightness to 31, that's the max. The red to 0, the green to 0, and let's put the blue at 255. And then let's do an SK update to send it to the thing. And it works. Okay, so let me shoot. Where is my OBS? So I'm gonna go ahead and show you guys on the camera here, on the webcam. Jesus Christ. Oh yeah, let me turn my lights down so you can probably see that better. Off and off. Okay, so if you can make it out, it's the 1 2 3 4 5 6 7 8 9 10 11. Well, because I start at 0 0 1 2 3 whatever, 10. So it's the 10th LED with the blue all the way to right. So let's go back to our code. Maybe we can not do that. Maybe we can cycle through the entire strip and have it go for blue, right? So let's do, I mean, you'll have 244. Yeah, I have enough. I was gonna use a 16. So again, we have I here. So let's do for let's see, I'm just gonna cycle through all the LEDs for I equals 0 or I is less than LED count. Let's do, we're gonna set all the LEDs. Okay, set LED index I, right? Index I, the global is gonna be 31, and we're gonna do red. Let's just do blue again. I like blue, green 0, and then blue is gonna be 255. So we're gonna do that, and then we're gonna do update. Oops. Okay, update. So we're gonna do that, and then we're going to turn it off. So it's gonna go through all the LEDs, turn them on, and then turn them off. With no delay, because well, maybe here we can test our code. What happens when you send 0? It should work, I think. Oh, 2 warnings. Pointless comparison us on the integer with 0. Oh yeah, that's true. This needs to be an integer, or else we're gonna have an infinite loop. Let's see. 1 warning. Expression has no effect. Oh, what do you mean? Or oh my gosh. Guys, I wish there was like live commenting and you can tell me my mistakes when I make them. Anyways, there you go. Okay, now if I'm gonna switch the camera, here we go. And it's cycling through all the LEDs. And it's turning the blue one on and then turning the blue one off. And obviously this is just a basic, I guess, proof of concept or whatever. Very basic driver. You can take that and run with it and make some animations, color fades. You know what I mean? So yeah, I'm not gonna make this video any longer. I'm already at 30 minutes. I do that every freaking time. So that's it. That's the little driver, and that's the SPI in action. Yep, enjoy. Oh yeah, and the parts, the LEDs are the SK9822. Try to post some links on the YouTube channel for those. They're a lot better in my opinion than the Adafruits or the NeoPixels, because those use just one wire for communication. So can you imagine, you know what I mean, it's a lot slower. So if you're doing anything with like persistence of vision or anything like that, you're gonna need something that you can clock a lot faster than those. Unfortunately, these, I don't know why these, I can't get them to work any faster. As you can see, I'm not using any delay and it's still so slow. At the same time, you got to think about it. When I turn on one LED, it has to send 144 times 4 bytes plus the start and the end bits, and then it's going to turn on one LED. Then it's going to turn on the next LED. It has to send the data to all of them. So I mean, it's insanely fast what's happening, but it could be faster. All right, guys, take care.